Okay, so good afternoon, everyone. I'm Robbie Jerrom. I'm a Principal Solution Engineer at VMware, and I like to talk about things that are coming from VMware soon, on the horizon, or interesting things that might break. So today I'm going to talk a little bit about the Tanzu build service and the Tanzu Cloud Native Runtimes, how they fit into the kind of bigger picture of apps, and how it's just going to make life easier for everybody. As I go through, please ask questions. I'm pretty certain I don't have a full 45 minutes worth of slides, and I've already broken my demo. So ask questions and we'll have a bit of a longer discussion. So to start with, a bit of a history lesson. Way back when the world was new, building software was difficult and slow. And then came this amazing solution, this PaaS solution in 2007-ish, called Heroku. And it was incredible. It was built on the premise of taking my source code. It would work out what the code was. It would then build the code and deploy it into its PaaS platform. And way back in 2007, that was unheard of. And Heroku spawned a whole bunch of interesting pieces of technology, including Cloud Foundry and Docker and stuff like that. 2009, we had version 2 of Heroku and Cloud Foundry emerged. Both with the same premise: here's my source code, run it. I really don't care how. That was magic. It was kind of visionary, but it was very opinionated. So it was difficult to do everything that enterprises needed to do for those solutions. But the fact that you could understand the source code and then just build it was very clever, and that persisted through to 2018, 2020. Where the folks at Pivotal and VMware came together with the folks at Heroku to create the Cloud Native Foundation build packs. So build packs have been a concept for, over a decade now, just understanding what your code is and how it's built. But in reality, software, I say used to be built like this, but most enterprise software is still built this way. We have virtual machines or physical servers. We have Java virtual machines, and then those build pipelines are typically Jenkins. And Jenkins has a number of VMs that are effectively build servers that sit underneath them, that take your software, take your code, and follow a very prescribed set of instructions as to how to build that code. Back when I was doing this stuff for a living, building WebSphere, we had build scripts that created make files, that created Jenkins configs that would eventually then start building your code. And the Jenkins build farms that we had were huge. You would have master node, you would have 20, 30 agents on other virtual machines just building Java code for my application. And it was incredibly complex. And the architecture on the right-hand side of this slide is an actual architecture around a build environment for a data platform that I was reading about on the web, and I just love the graphic that it highlights how complex building software can be. Installing plugins, configuring build spaces, making sure you don't run out of storage, auditing all of those changes. So when you build a new version, making sure you've got the exact right pieces in the right places so you can reproduce that build if it goes wrong. It's incredibly complicated, and that's why you have build teams. And most organizations today still have a build team, or at least one individual that understands how their software product is built, and that's all they do. They don't do any code, they don't do any feature work. They just understand how to build the thing, package it, and push it out. And that's time consuming. It's complicated. It's risky. It always has been, but it's started to become easier. And the concept of what we did with Heroku and Cloud Foundry, moving that forward to allow you to build software the way you want to build it, which is slightly less opinionated than the likes of Cloud Foundry and Heroku, is at the heart of build packs. Build packs keep the intelligence, but give you that flexibility. Predominantly because we now have Docker and we have Kubernetes, and the world of software engineering and infrastructure teams all rejoiced because it's all very easy to understand and manage and all of that stuff. which may or may not be true depending on where you sit in the world. It's possibly not simple for everybody, but it certainly made the process of repeatability much easier when you're building software and then deployment inside Kubernetes. So as I said, Heroku wasn't just magic. Developers still had challenges. And that was around all they really needed to do was write code. They're writing business code, they're writing applications to solve business challenges. But there are a number of steps to packaging something into Kubernetes and building it in a Docker container. So to start with, we have Docker files. So we take the application component, we describe in the Docker file how to build that particular piece of software and how it's labeled and how it interacts with other pieces. So now I've got another artifact that I need to care about, I need to look after. I need to version control and make sure it's up to date and check. And that gives me my container image, which I need to label and tag and push to a repository and look after and check. And then I have the actual how to deploy the application itself. So this is Kubernetes resources. This is how it actually deploys into Kubernetes, what persistent volumes it might need, what other pieces it might need to be successful. And then the services themselves. What am I going to call them in Kubernetes in production? And I need to synchronize those, make sure they're consistent and version control all of those config files as well. And then finally, I get to run it on Kubernetes. So as a developer, I have to do all of these steps. The writing code is the valuable piece. That's where I'm using my brain to create the next Netflix or something like that. And then everything else there is quite a distraction. It's important. I need to do all of these things to get my software into production and to enable it to scale and use the features of Kubernetes. But it distracts away from building my application. So that's not really where I should be spending all my time. And there are other concerns as well. So this is actually quite a long process to getting my code into a deployed environment. I mean, it's certainly not as long as it used to be with Jenkins build farms. And, you know, in that world, if I needed to build something new, I'd spend weeks creating a new build environment for it and deploy that somewhere in a bunch of VMs in a Jenkins farm or have to stand up my own. So it didn't take me weeks to write this stuff, but it would still be long enough to let me lose focus maybe on the code that I'm writing. And it's distracting me away from the actual business logic that I'm trying to solve, the feature work, the actual value to the organization in building all these different pieces. And then there's a big part around security and consistency. If I'm one of 10, then maybe I can synchronize with everyone else in my team around, you know, Docker files and labels and configurations for my Kubernetes deployments. But if I'm a large organization with lots of different teams doing all kinds of different things, keeping these pieces in synchronization is a challenge. And making sure they're secure is also a challenge. When I'm building an application and I'm using a base image, say Ubuntu as my base file system for that container image, making sure that that container image is secure, is up to date, is the latest version, is time consuming. And if there's a CVE that, you know, in a tool inside that container image, I need to be able to catch it. It's my responsibility as a developer to make sure I'm writing secure code. And that includes all of the layers of that Docker file that deliver the application end to end. Now, I may have a DevOps team that help me with that and look after it. But fundamentally, how I package up the specification in the Docker file, how I build my app, the security of that is my responsibility. And if there is a vulnerability, I need to go back and I need to edit those Docker files. I need to change them. I need to fix the problem. So if it's something like a heartbleed or something like that we like to refer to because it's an easy one, but we need to go back and fix it. And so I need to edit all of those Docker files. I need to version them. I need to redeploy the images. And it takes time and it distracts away from me writing my code. So if I'm spending too much time distracted, what can I do about it? What should I be doing about it? Well, really, I need to automate that. And it's the same as what we did with VMs, automate as much as possible to get the pipeline through to production as seamless as possible, as smooth as possible, as consistent as possible. So taking away the responsibility of creating those Docker files, building the images, defining the Kubernetes resources, accelerates my path to production. We still want control, we still want audit, we still want security, but we don't really want to do that ourselves. It'd be much better if the machine took over that responsibility, and that's what we're doing with Tanzu Build and with Cloud Native Runtimes. Tanzu Build is responsible for understanding the application and writing, the Java code, the Go code, the COBOL code, if it's even COBOL, and creating the container image. And then Cloud Native Runtimes, effectively a serverless component from Knative, gives you the ability to deploy it into that Kubernetes cluster and configure up all the things you need, all the services, all the things like SSL certificates and stuff like that, handle scaling for you. So you're reducing the complexity of that production side as well, just to get the application out to be able to test it and run it. So that's awesome. So taking source code and saying, just take the code, work out whether it's Java, work out if it's Java 11, Java 13. If someone's created some Go code in there, just work that out for me as well, and create the containers required. So now if I'm writing some Java code and I'm using a feature in Java 13, the build service is going to work it out. It's going to package the right Java runtimes for me to deploy into production. I don't have to go into a Docker file and say, actually, now I'm using Java 13 for this, increment this version. It's going to work it out for me. So it takes care of all the updates. It takes care of all the dependencies. And if I'm building an application that has a whole bunch of things like a Spring Boot application, it's going to pull all of those pieces for me as well. So I don't have to care about it. It's just going to look after them. But what's really nice about this is in enterprises, we don't necessarily want everyone just pulling stuff from the internet. That's possibly a bad idea. If I've written some code and I'm using a repo from bobsrepos.com, and it's an encryption algorithm that I really like because my mate wrote it, I don't necessarily want that to be part of my build. Enterprises don't want that to be part of their software stack. The same with licenses. Lots of open source software has different licenses. So we need to make sure we're compliant with licenses. So what we can do with build service is we can either leave it fully open and you can download whatever you want from the internet and build the application however you need, or you can create a subset and we can say, this is our marketplace of known base builds. So this build environment knows how to build Java 13. It knows how to deploy Spring. It knows COBOL. It knows all of these pieces that as an enterprise are acceptable for us to be able to deploy and build applications against. So it's giving us control. And I can do that in an offline mode. So I can download all of these build packs and tie it down. So the safest way of building software, if you're not sure what's being downloaded and packaged up, is to build in an isolated environment. Press some magic, apply some NSX magic, deny the build environment access to the internet. That way, the software that you're building is from known repositories, safe locations, and you can't have a developer accidentally introducing an artifact that just shouldn't be pulled down, shouldn't be built. A big concern with security today is open source projects that are being contaminated over a number of months or even years to introduce exploits. So organizations are very, very concerned with this is an open source component, that's fine. We understand it, we know this piece, we've audited this particular piece. We don't need any more functionality on this at this time. This is the version we're going to build against. So applying that as the base image, the build packs you can work against, helps you guarantee the quality of the software that you're building. You're not accidentally going to be picking the latest version that may have something in it that you're not aware of. So reducing risk by controlling the build. And then on the other side here, we have Cloud Native Runtimes. And that builds the Kubernetes resources. So that looks at the container images, that looks at what's being deployed, and takes care of revisioning, URL generation, lets you scale down to 0. So it's being able to make more effective use of your Kubernetes cluster, and not having to hand crank any of these pieces. So when a new piece of code is deployed into the cluster from a build, a new container image, a new application, I can create a revision. Say this is revision 2.0 of my application. The Cloud Native Runtime is going to come back with the URL. It can create the HTTPS certificates and all of that stuff for you. And you can handle traffic as well. So we can say, based on demand, start at five instances of this, automatically scale up based on demand to a maximum of say 20. Or if there's no traffic coming into the application, scale down to 0, save my resources for something else. So we can start to be very efficient with it, all without having to manually configure these things. I don't have to go in and scale, say, deployments down to 0 to scale the application down. I can scale back up based on requests that come in. So we're making the runtime as flexible as possible as well. I can balance traffic between them. So if I've got version 1 and version 2, I can split 50% of the traffic between the first version, 50% between the new version, observe the results. If it's going very badly wrong, the application isn't responding how I want, I can redirect all that traffic to the old version that's already running. That old version will automatically scale up to handle that demand. And I can go back and fix whatever the new changes in my code were, push them through build service, get a new container image, and try that loop again. So it's a nice fast iteration to fix problems without me having to go in and manually reconfigure all these different components inside Kubernetes. So that makes sense, folks? Silence. No sense at all to anybody.
Great, Robbie.
Cool. I mean, it's as I said, there's a big beta logo over the Tanzu runtime for a very good reason. It is definitely beta at the moment, but build service is GA, and that's part of Tanzu Advanced, and that's out there today, building and doing magic stuff.
Can I just ask a quick question on that, Robbie? So where the build service is looking at those container images, etc. I mean, does it do scanning of that natively, or does it have a hook out to some other kind of scanning tool set?
It's not doing vulnerability scanning. So your repo will be doing that for base container images. But what it will let you do is lock it down and say, actually, you're only allowed to use this version of Ubuntu as part of build, or this version of Java from Oracle's certified containers part of your build. Yeah. So you can restrict access. It's not going to do vulnerability scanning. But what it will let you do is, if there is a vulnerability, you can explicitly say, replace this layer of my build with this layer that I know is good. Without having to rebuild the whole application.
Sure. I mean, can it do some kind of chain of custody, or look at hashes of known images in your repository, for example, so that they haven't been sort of tampered with on the way?
Absolutely. You can refer to the images that you're building through the hash directly, so you can make sure you're building against exactly the image is approved, is tested, and is consistent with your prod environment. So you aren't limited to just version 1 or whatever it's been tagged by. You can use the SHA on layers.
Cool. Thanks.
Cool. Okay. So quick word of warning. The combination of Tanzu build service and Tanzu runtimes is not a full CI/CD pipeline, which I think touches on your point, Simon. There's lots of other pieces you need to put into your pipeline to deliver that end-to-end automation for path to production. Okay, this is a build component that does a great job at understanding the code that is being presented to it and packaging up and building that into the OCI compliant images. And then the run side is great at taking that image and saying, this is what I need to run it. And based on the config you've given me, I'm going to scale starting at 0 instances. And when I get an HTTP request come in for this application. I'm going to quickly cache that request, spin up an instance of the application, deal with the request. And as more traffic comes in, I'm going to grow the number of instances of this application to scale appropriately automatically. Or it's going to handle traffic balancing and stuff like that. But the combination of those two things does not give you a full CI/CD pipeline. You still need to do your testing. You still need to do decent load testing. You still need to do lots of other automation around this. Plug that into maybe a security scanner or an audit tool. So that this isn't replacing tools like Argo or Tecton in the Kubernetes world. It's just making individual parts of that pipeline easier to configure, easier to manage, and therefore easier to understand when you start delivering this as a service. And I often get asked, well, that build thing isn't responsibility of an infrastructure team, but that run thing is. But in reality, as software, and we all hear this all the time, but as ops and developers start to become closer together, they're both working with Kubernetes platforms in slightly different ways. Sometimes they don't have any idea how either side of these things work. So bringing dev and ops closer together and giving developers the ability to use cloud native runtimes to provision a test environment that auto scales means they can test their software more effectively. Using the same CNR cloud native runtime inside an operations environment where you're running thousands of instances means that you speak the same language as the developer that tests it on 5 instances. So when it does go wrong, you can go back and you can say, look, this is what we've built. This is how we deployed it. We're deploying it in the same way as you're building and testing. And that configuration is the same as in your pipeline. So you're bringing the languages closer together. And that generates interest from dev and understanding from ops as to both worlds. And it works quite well. And generally, I see dev and ops teams now working together on those pipelines, either delivering them as a pipeline service or just sitting with the developer saying, look, what are you building? How are you building it? And what other parts of that CI/CD pipeline are you putting in? If they're using linters to optimize the code, understanding what that is doing, what that's ripping out, what that's changing can be interesting to an ops person. So those are all sort of parts of these pipelines. And then on the tail end, depending on what you're doing sort of in the whole GitOps arena, having that pipeline actually provision up the Kubernetes clusters, deploy cloud native runtime into it, then deploy the application into it completely from clean is very attractive to some organizations that want to make sure their environments are as clean or secure or running as cost efficiently as possible, depending on where those workloads are landing. So I'm sure there'll be future VMworld sessions and VMUG sessions on Argo and Tecton and the whole CI/CD pipeline running in Kubernetes coming soon, hopefully. But these are 2 pieces of that puzzle. They're not an end-to-end solution. Okay, so how does it work? I've talked a little bit at a high level. I'm going to go into a little bit more detail now. So with your Kubernetes cluster sitting at the bottom, we deploy Tanzu build service. Build service effectively has a service called custom builder. And the custom builder is responsible for understanding the source code and consuming creating stacks from what we call the store. The store effectively is a marketplace of known components that you're allowed to build from. So the store is where you would put Java 13 images, the Go builder. If you had some COBOL code, you put the builder in there for that. And then when you create a stack to build your application against, that stack consumes from that store. So when we look at the code, the source code is going to be the stack, the custom builder builds it. It consumes from the store of what available images are available to you as part of that build stack. That's going to build the image, push that out to a container registry, and be your application. Knative serving, which is the cloud native runtimes, is going to consume that container image from that registry when it's ready to go. So as I say, demo time. I always like to build a live demo and show something. We'll see how well that goes today. But what I've got to to talk around is a Spring Pet Clinic application. So Spring Pet Clinic is a Java microservices application that we use for all kinds of sort of education, training. It's been around in the world of Spring and Java for a very long time. So it's a great demonstration of various parts of software architecture and deployment. I'm going to use that in my Tanzu build environment to build a version of Spring Clinic. That's going to push out to Docker Hub, and that's going to give me my container registry. And I'm purposely making this both internal and external to show the variance here. And then Cloud Native Serving is going to pull those container images, deploy those into the Kubernetes platform, the Tanzu platform, and it's going to secure those with Let's Encrypt certificates that it's going to automatically pull down when that deployment happens. And then the logs of those builds and that activity, because everything is in Kubernetes, is treated the same as everything else. So if a build is failing, the code isn't compiling, or it's not assembling correctly, all of those errors are just events or logs inside Kubernetes. So you can consume them however you want to consume any other Kubernetes log, or you can just forward them off to a development team to look at later. So there's consistency in how you understand the platform. Now the logs for the build environment are in the same place as the logs for the production environment, or the events for pulling images from Docker Hub, for example. So everyone is using the same tool sets and the same terminology to understand what's going on, whether it's broken the Java code, broken an SSL certificate, or there's a permissions problem. It all happens in the same place. The logs are all in the same place, and you can see what's going on. So that's what we're gonna do today. We're gonna deploy some code, build some code, and then hopefully push it out into production. So I'm going to switch. Oh yes, and none of this is also on vSphere. I thought it'd be an interesting experiment. I normally build everything on vSphere and run everything on vSphere. Today I'm not doing anything on vSphere. This is Tanzu deployed onto AWS. This is certificates from Let's Encrypt. I'm not even using Harbor as my repo. I'm using Docker Hub as my repo. And GitHub as my source repository. So lots of different pieces. And as I said in the chat earlier, not all of those pieces are actually working the way I want. But yeah, this worked nicely on vSphere, then I moved it to AWS and it's become complicated. But I'll get into that in the live environment. So let me just switch to my screen. All right. Oh, why can't I share just my desktop? What's going on?
Yeah, I think this might be a policy. I think this is a Zoom policy challenge with UBS. I think when you're sharing externally, it doesn't allow you to share your desktop. It allows you to share windows.
Okay, I can get around that. 1 second. No, I can't. That's not going to work. Okay, we might get a very boring console window for a while then. No, I'm going to be switching. That's not going to work. I'm going to be switching backwards and forwards. Any suggestions, Simon?
Depends where you want to run your bits from. We've cheated it in the past with RDPing to something and sharing the RDP window, but I don't know whether that's an option for what you're doing.
That might. Well, let's try that.
Yeah, it seems to be a policy that's set on the VMware side. I think it's okay if you're sharing internally with other VMware people, but where you're going externally federated, it doesn't let you.
Right, okay. Let's see if this will let me do it. No, okay. I'll switch between windows and see how we do. Okay, so what are you guys seeing right now? Is that just
build logs console?
window? Okay. Not sure how well this is going to show, but we'll see how we go. Actually, if I take that, I can share a single terminal window, then I can split that out. Let's do that. All right, is that, are you seeing a multi-tab tab console now?
Yeah.
Okay, so I've got my Kubernetes platform. I've got my Tanzu build service deployed into that platform. I'm just having a quick look at my cluster store. So if I clear this, I'm asking the cluster what it knows how to build. So these are particular build packs from VMware for building Java, Nginx, Node.js, Go applications. And I can add to that store, whatever I want. So I've got the predefined packs available from VMware that we look after, we certify and we check for security, etc. I can also add my own. So there's a Payco build pack up there. There's build packs available for pretty much every language, I think. I mean, I was looking at a COBOL one the other day just for pure interest. So I can load those into the store and make them available for anyone who wants to build their application. So that's what's available for me to build. Now, if I want to build something, let me just stick the build logs in a different window. Okay. So if I want to build something, I can just submit that build environment to the build service and say, this is my GitHub repo. This is where I would like you to build from. So for my application here, if I want to deploy, I want to add that, I can create what's called an image. will let me build into or take advantage of build service. So if I go from my console here, I can do I'll just paste this in. So I can do a KP, I can do KP image create. So create me a new image. It's called Spring Pet Clinic. This is the Docker repo I would like to push it to. And this is the source code of the Git repo where the code is. I want to build against the main branch of that code, and I want to push it to this namespace, so the TBS demo. And that's going to, so it already exists, that's going to connect the build service with the source code repo on GitHub and the Docker repository where I want that image to be pushed to start the build and kick everything off. The build takes about 15 minutes, so I've already pre-built that, pre-cached all the images. What I'm going to do is I'm going to make a change so we can see the build kick in. So any time a new commit is made to the Git repo in the main branch, Tanzu build service is going to pick that up. It's going to rebuild the images for me and make them available on Docker Hub. So if I go to my watch, it's a shame you can't see me change the code, but I'm just going to make a quick change to the code, push that up to GitHub, and it will detect that and start building. Let's keep this watch off. Oh, there we go. So it's detected that there's a new code build. It started the build process. Spring Pet Clinic. Then why my logs aren't coming up. Hold on a second. Oh, it's still building. So if you head over to Docker Hub, that's the repo that is currently being built. So you'll see that populating and building. It's a shame I can't share that on the screen. Oh, it's finished. Okay. So now it's made. Now it's finished the build. I can just push that down to my environment and say deploy that image. So I can now switch to Knative serving, and I can say to Knative, deploy my application for me, and make it available. So I can say Knative service. I don't want to update. I want to build. I want to create Pet Clinic. Create my Pet Clinic, which is a revision, which is the name of my deployment. This is my image from Docker Hub that I want to deploy, and I want a minimum scale of 3 of these at any given time. If I were to set this to 0, the deployment would sit and wait until someone hit the end point, URL, and then it would spin up an instance of that application. What's great about this is though that even though there's no instance available, no pod running when that request comes in initially, that initial ping is held and replayed effectively when the container becomes available. So we can scale right down to 0, and we're not going to miss any requests coming into this service. So now Knative is pulling down the image, it's configuring up the pet clinic, it's setting up the network. It may or may not be going off to Let's Encrypt to get me a certificate endpoint, because that was the problem I had with the lab environment. So there we go. We've got my application deployed. If I do my Knative service list. This is my pet clinic here. This is the URL it's deployed to. This is the latest revision that it's got, and it's running 3 instances and it's ready for traffic. If you go to this endpoint with your browser, you'll probably get an error message. If someone could do that and tell me, that would be great. Yep, I'm getting an error message. So the reason that that's throwing an error out is because I'm deploying this platform in AWS. It's automatically trying to switch to use HTTPS to stop cross-domain certificate cross-domain issues. So the load balancer is an AWS name. My application is deployed on Tanzu.app, and the backend services have got different names themselves. So by default, the browser request will switch straight to use HTTPS. I did configure up the Let's Encrypt issuer inside Kubernetes to automatically pull that piece, which is once again something you can set up in Tanzu runtime. But I think I've hit an API limit where it's not issuing certificates anymore. So I need to create a new identity or wait for that to come back. When I'm allowed to issue new certificates, that will switch to HTTPS, and you'll be able to hit that and see the application. But I don't think that's going to be today. So the next thing I want to do is just deploy another instance of the application. So if I push down another instance of it, I don't need to create another build. I can just deploy another and give it a different name to give it another revision. I need to give it the right repo though. So now it's creating another revision of the application. So if I had a build service update the application, push that to GitHub, push that up to GitHub, push that up to Docker Hub, I can say to Cloud Native Runtimes, deploy a new version of my application, and then I can choose to balance the traffic between those two and evaluate what's going on. So it's once wait for that to come back up, and then I'll just set a policy around balancing that traffic. Oh, there we go. Okay. So now if I look at what I have in terms of services, I've got version 3. And here's my revisions. So because I provided the wrong repo here, I've got an image, an error saying that this is not a valid revision. And so I can delete that. This is a bad deployment. I don't want it messing things up. I've got version 1 and version 3, or generation 1, generation 3 of my application. Now, if I wanted to balance the traffic between them, I could say update pet clinic, and I want to change the traffic For this version here, version 3, which is my new version, can have 20% of the traffic. Version 1, I want 80% of the traffic. So now the traffic is automatically routing between two different versions of my application, so that I can make sure that everything's good before routing 100% of the traffic to version 3. So once I'm sure everything is happy, I can say, right, route everything to version 3, and I'm good to go. But if something does go wrong, I can go back to previous revisions of those deployments, and I can have as many of these as I want. I can clean them out, but effectively, because they're not using much resources, they're sitting at 0 pods running unless something hits them. I can easily roll back to previous versions, as many as I want. And I can, because this is Kubernetes, I can put name tags on these, selectors on these. So I can put detail behind each one around what a particular change was, for example. So if I do kn service describe, so I can see specifics about that particular image. So what image it was pulled from, what version, what it was pinned to, how long it's been running, all those kind of details. If I describe the particular revision, it's going to give me specifics about exactly what I'm running, what policies around it, what labels, what namespaces. So it gives me details about those deployments, even if they're not doing anything. So I've got a nice way of building an application in an automated fashion. I can choose what particular layers of an application are there based on the shards, or I can pull that config from the net or consume it from a marketplace using the stores that I've predefined. And when I come to deploy that out using container cloud native runtimes, I can scale from 0. I can set policies on how to scale up and scale back, and I can automatically create the HTTPS certificates and then deployments around them. So I've got a very easy way of taking code from lines of code in a Git repo, building it and pushing it down into production very easily. And that is unfortunately just a console demo, but hopefully that was useful. Any questions on any of that, folks?
It was really good.
Yeah, really good. Thanks, Robbie.
I mean, just I mean, obviously we're only able to do the console demo, but does that then imply there's a kind of, I don't know, is there a web-based UI to navigate that in a slightly less command line fashion?
No, it's very developer-y, so it's very command line, but the goal of it is it just gets built into a pipeline. So you really want it command line.
Yeah.
It's more useful to have. So I have Octant running, so you can see the pods scaling up and scaling back. And if you're watching the build logs and the application run logs, you can see the app starting and responding to requests. So the desktop was just to make the demo more interesting for you folks. Most of the stuff that's coming out of Tanzu build, cloud native runtimes, it's all command line by intent. Now with Octant, there's already a cloud native runtimes plugin, so it understands that you're running using cloud native runtimes, and the GUI changes to show you more of a real time view of what's being deployed and what's being configured. So it's those third party, it's those open source plugins that give you that kind of GUI experience when you're trying to understand what's going on.
Cool. I mean, just in terms of telemetry, I mean, I mean, obviously you can have conditional branches and things like that, and you build scripts based on output. But is there somewhere central that you can send telemetry data? Because if I think about the way I potentially do some of that stuff in some of the other sort of large cloud providers, you can pump all that kind of log data at a logging solution. Do you have a similar sort of capability so you can see where you're starting to have failures?
Yeah, absolutely. Because it's all using Kubernetes primitives. They just go to Kubernetes logs, so you can pipe them wherever you want. So if you've got like if you've got build tools that analyze that already for you, you can just consume those logs. You could push it to a log insight or or whatever you want, or a Splunk, and just interrogate it from those places. It's the same as if you've got build failures and you want to be able to trigger events based on those failures, you can watch those logs and just pick up on those events and send out push notifications to developers if you want. You can use the the cloud the AWS messaging services to send text messages to dev teams if things are failing, builds are failing. But because it's all effectively using the same fabric, you've got a lot of flexibility as to how you choose to interact with those teams. So when I'm playing around with this internally, whenever there is a code commit going up to something I'm working on, you get a notification in a specific Slack channel. And if the build breaks, you get a chunk of you effectively get 10 lines of the previous log showing you where the break happens. Because ideally, no one should be pushing code into a repo that's going to break it. But if it does, you can quickly see what the error was, what the break was, and who made the last commit into that branch. So you've got that flexibility, and it's very easy to configure and very easy to set up. And that's the goal with a lot of this stuff. Is it's easy to integrate it into the systems and services that you're familiar with. The batteries are included but changeable, as they say.
Yeah, I'm envisioning an API to send the lads around when things break. Rather than
exactly. But if you start to automate this stuff, which is what you want that path to production. But equally, you absolutely need to be able to roll that out or to fire up the fireworks if something has got to production that is causing a problem. And one of the nicest features of Tanzu build is that the Spring app, for example, that takes about 15 minutes to build. But if you are building a big enterprise thing, that can take a lot longer. If there's a vulnerability in one of those layers, or you need to change one of those layers from Ubuntu 16 to Ubuntu 18, you can change it in the build in Tanzu build, and it's going to rebuild all of those pieces that are dependent upon it. But it's not going to. It's going to do incremental building. It's not going to respin everything. So it gives you that control on the build side, where you're not going to impact things you don't need to, and you're not going to have to rebuild everything just because you need to move to a new supported file system that you've built your applications on. So it gives enterprises more control and more visibility, and you won't find that your Spring application or your Java application is using a Java library that was built a decade ago and no one realized, because you've got that visibility into what's being built and how it's being built. I think I'm out of time, but
yeah, so we're in a break technically. So I think we start at the top of the hour for Gary's session. But we got any more questions for Robbie? Just not to let him escape early.
Well, thanks for staring at my console for the best part of 20 minutes. Sorry it wasn't more graphically exciting. Next time I'll make it better. No questions? All right. Thanks very much, folks.
Thanks, Robbie. Cheers, Robbie. Thanks, man.